To edupediaworld.com. You're watching the videos on quadrilaters. So in this video we'll discuss questions on midpoint theorem, so which are very important questions from the exam point of view. So let's discuss the first question. The question number 1 says that ABCD is a quadrilateral in which P, Q, R, S are the midpoints, means these are the midpoints, and on the sides AB, BC, CD and DA respectively, and AC is a diagonal. So first we need to show that SR is parallel to AC and SR is half of AC. So let's see how we can do this. Now, if you consider triangle ACD, so this is a triangle if you can consider ACD. Now, in this triangle, we can see that S is midpoint on side AD and R is midpoint on side CD. So according to midpoint theorem, the line joining the two midpoints of the sides of a triangle is parallel to the third side and it's a half of the third side. So we can say that in triangle ACD, S and R are the midpoints of two sides of triangle, right? So SR is parallel to AC and SR is half of AC. So we can say by midpoint theorem. So this is a midpoint theorem, how we can use this. Now next we need to prove this. Next part is PQ is equals to SR. So we need to prove that this equals to this. Now, so again, if you can consider triangle is ABC, in this triangle P is midpoint of AB and Q is midpoint of BC. So again we can say that the line joining the two midpoints of two sides of a triangle is parallel to third side and it is half of third side. So we can say that in triangle ABC, PQ is parallel to AC and PQ is half of AC. So by midpoint theorem. Now, since we have SR equals to half of AC, let it be first, and PQ is half of AC, so let it be second. Now from 1 and 2 we can say that PQ equals to SR. So this is how we can prove the second part, and PQ is also parallel to SR. Now, so last part says that we need to prove that PQRS is a parallelogram. So how we can prove that? So we need not to prove this part since we have already proved that PQ is equals to SR and PQ is parallel to SR. So if in quadrilateral, if you can consider quadrilateral PQRS quadrilateral, one pair of sides are equal and parallel, so it's a parallelogram. So we can say that PQRS is a parallelogram. So this is how we can prove these type of questions. So let's move on to the next question. The question number 2 says that ABCD is a rhombus, and so let's first draw the rhombus. A, B, C, D and PQRS are the midpoints of the side AB. So let this be P, let this be Q, and let this be R, and let this be S. So these are the midpoints. So this is the midpoint, this is the midpoint, this is the midpoint. Now we need to show that the quadrilateral PQRS is a rectangle. So we need to prove that PQRS is a rectangle. So let's see how we can prove this. First of all, we need to write given. It's given that ABCD is a rhombus. So in rhombus, all sides are equal. So we can say that AB equals to BC equals to CD equals to AD, and diagonals bisect each other. Now, so let's see how we can prove this. So if you can draw a line like this, let's say, or we can draw a diagonal AC. So now if you consider triangle ACD, so in triangle ACD, S and R again the midpoints, and these two midpoints are joining the two sides of a triangle. So again by midpoint theorem we can say that SR is parallel to AC and SR is half of AC. So we can say that SR is parallel to AC and SR is half of AC. Why? Because S and R are the midpoints and SR is line joining the midpoints. So by midpoint theorem we can say that SR is half of AC and SR is parallel to AC. Similarly, if you consider triangle ABC, so in triangle ABC again we can say that PQ is parallel to AC and PQ is also half of AC. Why? Again P and Q are the midpoints and PQ is line joining the midpoints. So by midpoint theorem we can say that PQ is half of AC and PQ is parallel to AC. So let this be first and let this be second. So from 1 and 2 we can say that, let's say, PQ is parallel to SR and PQ is equals to SR. So we can say that now PQRS is a parallelogram. So why it's a parallelogram? Since one pair of opposite sides are equal and parallel, so it's a parallelogram. Now we need to prove that PQRS is a rhombus. So let's say if we draw a line like this, or let's say we draw the diagonals of the parallelogram PQRS. Now since RP and SQ are diagonals of parallelogram, so we can say that RP will be equals to AD. Why? Because R and P are the midpoints joining the side, and so ABCD is a rhombus and it's also a parallelogram. So we can say that RP equals to AD. Why? Because R and P are the midpoints. So when you join the line R and P makes a line RP, so it will be exactly equals to AD because it's a rhombus and rhombus is a parallelogram, so the lines are equal and parallel. So we can say that RP equals to AD, so let it be 3 then. Similarly, we can say that SQ equals to AB. Again S and R are midpoints, and again ABCD is a rhombus, so it's also a parallelogram. So SQ will be exactly equals to AB. It will be also parallel to AB. So let it be 3 then, or let it be 4 then. Now, since we know that AB equals AB equals to AD. Why? Because ABCD is a rhombus. So ABCD is a rhombus. It's a given, right? So we can say that now SQ equals to RP. So we can say that PQRS is a rectangle. So why it's a rectangle? Because in a rectangle diagonals are equal. So since we have proved that SQ equals to RP, so PQRS is a rectangle. So why? Because in a rectangle diagonals are equal. So this is how we can prove these type of questions. So let's move on to the next question. Now this question says that ABCD is a rectangle. Suppose we need to draw a rectangle like this. So let's say we have a rectangle A, B, C and D, and PQRS are the midpoints on the side. So this is a P, this is Q, this is R, and this is S, midpoints. So these are the midpoints like this, midpoints. We need to show that quadrilateral PQRS is a rhombus. So we need to prove that this PQRS is a rhombus. Now, so first of all, we need to write given. So it's given ABCD is a rectangle and PQRS are the midpoints. Now, so let's see how we can prove this. So similarly, again, we need to draw a diagonal like this. So we draw the diagonal AC. Now, if you again consider triangle ACD, in triangle ACD, S and R are the midpoints, right? So again we can say that SR is parallel to AC and SR is half of AC. Again you can say that by midpoint theorem. Similarly, if you consider triangle ABC, again P and Q are the midpoints. So we can say that PQ is parallel to AC and PQ is half of AC, again by midpoint theorem. Right? So we can say that now PQ is parallel to SR and PQ is also equals to SR. So we can say that now PQRS is a parallelogram. Now, so we need to prove that PQRS is a rhombus. Now, since ABCD is a rectangle, so we can say that each angle is 90 degree. Right? Now, if you consider triangle SRD and triangle RQC, in these triangle, if we can prove these two triangles congruent, so we can prove that SR equals to RQ, then when all sides will become equal, so it will become a rhombus. So let's see how we can do this. Now, in triangle SRD and RQC, we can say that angle D equals to angle C. It's each 90 degree, and we can say that DR equals to RC. Why? Because R is a midpoint. So this side, similarly, so this side equals to this side. We can say that SD equals to QC. Again, we can say that S and Q are the midpoints. So we have two sides equal and included angle equal. So we can say that triangle SRD is congruent to triangle RQC by SAS. So these two triangles are congruent by SAS. So we can say that SR equals to RQ by CPCT. So since SR equals to RQ, so all sides will become equal. Why? Because PQR is a parallelogram. So if it's a parallelogram, so PQ equals to SR and RQ equals to SP. Since SR equals to RQ, we have proved, so we can say that PQ equals to SR equals to RQ equals to SP, right? So we can say that now PQRS is a parallelogram. So this is how we can prove these type of questions. So also we can say that PQRS is a rhombus, right? So this is how we can prove these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day ahead.